Hey, what's up guys? Today we're gonna create a Subgraph project using the Graph CLI. We're gonna start by hitting Graph init and giving a name to our project. Here I'm gonna select the Ethereum network and I'm gonna go with the default slug. You're gonna have to provide the contract address, which I'm gonna show you briefly how to obtain it. The CLI is gonna fetch the contract information, including start block and contract name. You can optionally add other smart contracts, but for the purpose of this tutorial, I'm not gonna do that. I'm just gonna head to the source code to browse what we have in place. The first file is the ABI, which includes the entities and their inputs and parameters. The next file that we're going to look into is the handlers file. The handlers file includes all the event handlers that are supported by this project. Our favorite handler for the purpose of this tutorial is handle transfer. The next file is network.json, which includes the contract that you just added with the address and the start block. Schema.graphql includes the schema of all the types that exist in this project. Subgraph.yaml includes the entities, the ABI and the location of the ABI file, event handler, and the location of event handler files. To obtain the contract address, head to the Etherscan, search the name of the token, and here you can find the contract address. If we go to the Graph Studio and connect our wallet, we can create a new Subgraph project. You need to define a name and create the Subgraph project. Here in the dashboard, you can add other information such as description, source code URL, website, and more. There is also some information about the CLI commands that you can use to build and deploy the project. Remember that you have to authenticate your command line. To do that, we hit graph auth with the code that's provided to us by the dashboard. The next step to generate the code and build it. Run graph codegen and graph build. Remember to switch to the directory first. Now that we have everything, we should be able to deploy the generated files. You need to provide a version number. I'm going to go with 0.1.0. You can make note of the Subgraph endpoints, which is required if you want to interact with this project using your other application, including client or API applications. The deployed version is syncing and the progress is going to continue until 100%. There's a playground which provides you with all the entities and event handlers that are available for you to play around and get familiarized. Let's fetch the first few transfers by the order of block number in reverse. You can see that it returns all the IDs, and you can add other values at your will. Next, let's remove every handler or every other imported entity that we are not interested in to make the code clean, and we can focus on the thing that matters for us. Same goes for the types defined in the schema.graphql file. I'm just going to keep the transfer type. In subgraph.yaml, remove all the irrelevant entities, meaning anything other than transfer. Save the file. Now we're ready to build the project once more and deploy it. Once the build is complete, you need to deploy, and for that, you need to define a new version number. You can find the deployed new version, and if you head to the playground, you will see that the other entity and event handlers are gone, and you only have meta, transfer, and transfers. Now let's head to schema.graphql, create a new type of the type entity, which will have an ID, a name, a symbol, and decimal points. We will also add another type called token supply snapshot. Token supply snapshots is another entity that has an ID, a token. This is the same token that we just defined, a supply, which is a big int number, and a timestamp. Let's add another property to the token type called total supply, and a supply snapshot property, which refers to the type that we just created. And we're going to derive this from the token field of the total token supply snapshot. Now let's take a look at the handle transfer. We need to create a transfer ID, which we're going to use to assess if the transfer is already recorded. Let's load the transfer using the transfer ID that we just created. And if the transfer didn't exist, we can create it anew. This means that we have to move all this code snippet into the if clause. We're going to take a similar approach for creating the token. Let's use the event address to identify the token, which we're going to import from the schema file. And if the token didn't exist, we're going to create a new one. I'll also need to create a contract variable, which is going to be a contract that we import from Polygon ecosystem, and I'm just going to bind it to event.address. Next, I'm gonna create the name result, which is contract.tryName. The contract has a few methods which we're gonna use to obtain the contract name, symbol, and decimals. I like to use ternary statements to define the fallback values for name, for symbol, and finally for decimal points. Fine. Now we can define the total supply of the token. Oh, I forgot that this is entity.total supply. This is gonna be a begin number from 0. The 0 is gonna be our starting point. And for begin, I'm using the library that Graph CLI already added to our project. Now let's save the entity. Let's build early on, so in case we have any errors, we can discover it. It seems that I have an error. Total supply has to be with capital B. Okay. Build was successful, and now we can deploy this version. To deploy it, we need a new version number. In the dashboard, you can see that the third version is being deployed. The first version is archived. And if we check the Explorer, you'll see that token supply snapshots, and tokens are the new collections that are added here. Token returns the value that we're expecting, and the total supply is 0 because we never stored any information other than 0 there. To store the information, we need to define a variable called isMinting. We define it by checking the sender of the event with the 0 address. For 0 address, I'm gonna define a constant value to be used later on. We also need another variable called isBurning. For which we're going to use event recipient with the 0 address. Actually, this is to and from, so I'm going to fix these, convert it to hex, and compare it with the 0 address. So if the event is a token sending from 0 address, we're minting. If it is a token that's being sent to the 0 address, we're burning the tokens. In any of these cases, the total supply is being changed. So I'm gonna define the change of the total supply, save the snapshot, and finally save the token. Let's define the change of total supply as the supply that already exists minus the value or plus the value that the current event transfers. If it's minting, token.total supply equals to the old value plus event.params.value. And if it's burning, which is the other situation, then we'll use the minus function to subtract it. Now let's save the token. It appears that TypeScript doesn't like the optional chaining, so I'm gonna move it to the else clause so I don't have to use it. Now let's save the snapshot. To do that, I'm gonna need to create another function to isolate or abstract out the logic that I need to handle this change. Let's define the function with the name that we provided. For this, I'm gonna need the event and the token. And it's not gonna return any value. Let's define the timestamp as the block timestamp. And let's define the interval in seconds. For that, I'll need to define the hour in seconds and day in hours. Now I can say the snapshot interval is 1 day. Finally, the snapshot time is calculated from this timestamp of the current block and the interval that we just defined. I'm gonna use the snapshot time to define the snapshot ID uniquely, meaning I'm gonna concat the token ID. Let's add a dash to make it readable with a timestamp. For that, I'm gonna use the token ID concatenated with the snapshot time, which I'm gonna stringify. Now let's create the snapshot using the class that I've imported from the generated schema. And I'm gonna use the unique ID that we just created to load any existing snapshot. And if it didn't exist, I'm gonna create a new token supply snapshot. Let's assign the token as the ID of the token that we're working on, and the supply as the token.total supply. And finally, let's define the snapshot timestamp as a begin value from the snapshot time that we just calculated. We're golden. Let's save it. Now we have a timestamp, which is 1 day, 24 hours. We created a snapshot time from the timestamp and interval. And we used the snapshot time and the token ID to create a unique ID, which we used to ensure that the snapshot is unique. Let's build it. Yes, we do have errors. TypeScript still doesn't like the optional chaining that we use. Let's remove them. Oh, we haven't even added the parameters. As you can see over here, we need to pass event and token. Remove that and this one. There's one more. This time it should work. Fine, let's deploy it with a new version number. Now let's head to the dashboard, and we will see that this time the snapshot is calculated and the timestamp is there. If you want to learn more, head to the endpoint and you will see that the Subgraph endpoints provided to us, there are samples to use from use curl, React. You can even see that there are implementation details such as the use of React query. There's also another small tutorial with Next.js and one more with Node. The dashboard also provides logs categorized by error, warning, info, and debug. Thanks for watching. Catch you in the next one.